Under catalysis, now we'll discuss about another type of catalysis called as enzyme catalysis. We have already talked about transition metal catalyst and their compounds. Compounds of transition metals and transition metals themselves can act as catalyst, important industrial catalyst. Now we are going to talk about another type of catalysis which is called as enzyme catalysis. As the name itself indicates, this uses enzymes as catalyst. Now first of all, what are enzymes? Enzymes are biochemical catalysts. Biochemical catalysts. These are catalysts which increase the rate of chemical reactions which take place in a living organism. In reactions which take place in the living organisms are catalyzed by certain substances called as enzymes. They are regarded as biochemical catalysts. Remember, enzymes are basically low molecular weight proteins. Enzymes are low molecular weight proteins. They are proteins with low molecular weight of the very close to a value of 40,000 units. Now let's see some examples of enzymes and the reactions they catalyze. Examples of some enzyme catalyzed reactions. Example 1, sucrose. Sucrose is a disaccharide. Sucrose breaks up into equimolar mixture of glucose and fructose. This reaction is catalyzed by an enzyme called as invertase. The name of enzyme is invertase because in this reaction there is a change in optical rotation, direction of optical rotation. You start from plus sucrose and you end up with a mixture of glucose and fructose. The mixture has levorotatory, the mixture is levorotatory. Another example for enzyme catalyzed reaction, glucose breaks up into ethyl alcohol and carbon dioxide. This reaction is called fermentation. It's an example of fermentation, and the enzyme which is responsible for this transformation is JEEMAINS. JEEMAINS enzyme catalyzes transformation of glucose into ethyl alcohol and carbon dioxide is produced in this reaction. I would like to tell you one thing. There is an important suffix which appears in names of most of the enzymes. Name of enzyme generally ends with ase. Okay. Now look at another example. Number 3. Starch. You know, starch is a polysaccharide made up of large number of glucose units. Starch is broken down into large number of glucose units, n number of glucose units, and the enzyme responsible for this is amylase. Amylase is an enzyme which catalyzes transformation or breakdown of starch into glucose. Number 4, starch in presence of an enzyme called diastase, it breaks up into maltose units. Starch is a polysaccharide and maltose is a disaccharide. I'll give another example. Maltose can break down into 2 moles of glucose. This transformation is brought about by an enzyme which is called maltase. The enzyme maltase will transform maltose into 2 glucose units. This reaction itself indicates that maltose is a disaccharide made up of 2 glucose units. Another example, proteins are acted upon by an enzyme pepsin. This is a exception to this convention. Is here the name ends with IN. Pepsin is an enzyme which is present in the stomach, in the gastric juice. It transforms proteins into polypeptides. So pepsin is an enzyme which transforms proteins into polypeptides. Another example is example 7. Proteins are broken down into amino acids. You know, proteins are made up of amino acids. So proteins can be broken down into amino acids. These are monomers. This is a polymer protein. It is acted upon by an enzyme, trypsin. This is present in intestine. So in the intestine, the enzyme trypsin breaks down proteins into amino acids. Urea breaks up into carbon dioxide and ammonia gases. This reaction is catalyzed by an enzyme called urease. Urease enzyme catalyzes breakdown of urea into carbon dioxide and ammonia. So these are some reactions, some examples where we see the role of enzyme catalyst. Larger molecules can be broken down into smaller molecules. For example, starch is broken down into glucose by an enzyme amylase, and then proteins can be broken down into amino acids by the enzyme trypsin, which is present in the intestine. So these are few examples where enzymes act as catalyst. Now let's talk about characteristics of enzyme catalyst. Number 1, enzymes work at optimum pH and optimum temperature. This is one important characteristic of enzyme. They work at optimum pH, which is in a range 5 to 7. pH range for optimum pH range for the enzyme action is from 5 to 7. And then temperature, optimum temperature should be around 30 degrees Celsius. This is the optimum temperature. So this is one important characteristic feature of enzymes. Enzymes work at optimum pH and optimum temperature. If the temperature is very high, then the enzymes lose their activity. Even if the pH is changed, if it is decreased or increased, then the activity of enzyme will decrease. Another important feature of enzyme is they are highly efficient. They are highly efficient. You require them in very small quantities. It has been reported that one molecule catalyzes, one molecule of enzyme catalyzes 10 power 6 molecules of reactants per minute. It has been estimated that about one molecule of enzyme will catalyze 10 power 6 molecules of reactants in a minute. So that shows high efficiency of enzymes. Let's learn about more features. We are discussing characteristics of enzyme catalysis. Number 3 in the list. Enzymes are highly specific in their action. They are highly specific in their action. That means a particular enzyme will catalyze a particular type of reaction. For example, any enzyme which can break down urea or an enzyme which can break down proteins will not be able to break down other amide linkages. So enzymes are highly specific in their action. Number 4, there are certain substances which activate enzymes. There are certain substances which can increase the activity of enzymes. Those substances are called as cofactors. Vitamins, certain metal ions can act as cofactors for most of the enzymes. Then number 5, there are certain substances which act as poison or inhibitors for enzymes. They decrease the activity of enzymes. See, most of the drugs work on this principle only. They block the active site of enzyme and prevent a certain type of reaction taking place in the living organisms. So, drugs generally behave as poisons or inhibitors for enzyme action. They generally deactivate enzymes produced by pathogens. That's about characteristics of enzyme catalysis. Let us now deal with mechanism of enzyme action. Mechanism of enzyme action. Imagine this is, E stands for enzyme, this is the substrate molecule. The first thing which happens is enzyme coordinates with substrate, you get an enzyme substrate complex. In this way, it can loosen the bonds present in the substrate. Then enzyme substrate complex decomposes in the next step to give product, and enzyme is regenerated. So, the substrate to product transformation reaction is being, there is an interference by enzyme in this reaction. It is, for example, it is making a one-step process go into 2 steps of lower activation energy. In this way, it is able to catalyze the reaction. It forms an intermediate substance which breaks down easily to give products. And to show specificity of enzyme, why enzymes are specific in their action, to show this and to explain the mechanism of enzyme catalysis, lock and key mechanism has been proposed, and the person who proposed this mechanism is, his name is Emil Fischer. A person by name Emil Fischer, he proposed lock and key mechanism for the action of enzymes. According to Emil Fischer, there are some cavities on the surface of enzymes. Enzymes are macromolecules, they are colloidal substances. So, there are some active sites on the surface of enzyme. In these active sites, some polar groups like carboxyl group, amino group, etc. are present, and the substrate coordinates with the enzyme at these active sites and will get transformed into product. Now, to coordinate with a particular active site, the substrate should have complementary shape. Then only it can fit in that active site and can get catalyzed. So, every active site has a characteristic type of depression, and any substrate which is having shape which is complementary to the type of depression can fit in that and can undergo reaction. That is lock and key mechanism which has been proposed by Emil Fischer, especially to explain the specificity of enzyme action.